Here we go for finding the convolution, discrete time convolution of two signals. The discrete time convolution of x of n and h of n minus h of n, that is half raised to n u of n. Here our signal x of n is u of n, which runs from 0 to infinity with unit samples, and h of n is half raised to n u of n. Half raised to n is a decaying exponential as it is multiplied with
So the convolution is represented as s of n here because one of our signal is x of n is u of n. So whenever we have u of n is to be convoluted with another signal, then we represent or we consider it as a step response. Given as the summation k is equal to minus infinity to plus infinity, x of k, h of n minus k. As we have x of k as the x of n signal itself, n replaced by k, and h of n signal has to be obtained as h of n minus k by replacing n by n
Let's
minus
find
k.
the convolution of,
So which is written in this way. Now this
of
s of
n
n is
and
nothing
h
but
of n.
the multiplication
X
of
n is
our x of k signal, x of k signal and h of n minus k signal. And the result of this summation is going to be 0 if x of k and h of k are multiplied and the result is going to be 0. And if they are existing at the similar values or at the same values of k, then it's going to be non-zero. So let's represent x of k signal, which is u of k, and h of n minus k signal, which is half raised to n minus k into u of n minus k signal. X of k, we consider it as a fixed signal, and h of n minus k is a moving signal. So x of k is fixed and it is running from 0 to infinity. And h of n minus k is a moving signal and it will be represented in this way. For better understanding, let's see this. So we have h of k signal. H of k signal would be represented in this way, and this would be our h of k signal like x of k. So which will be having the signals in this way. So up to from 0 to infinity, it would be running. Of course, it is with k. But for convolution, we need h of n minus k. To obtain h of n minus k, we time reverse this signal, and when we do that, to obtain h of n minus k, n is considered to be right now 0. So h of minus k actually it is. So just a time reversed version of h of k. So let's represent it as h of n minus k by considering n as 0. Now it is our h of n minus k signal, and this is h of n minus k, and this is x of k signal. The value of n is moving one, like we can take n as positive or negative. Right now it is 0 here. If n is less than 0, then this h of n minus k signal is going to be going, or it's moving towards left. And if n is greater than 0, then this h of n minus k signal is moving towards right. It's shifted to the right. By what value? If I take n is equal to, let's say, if I take n is equal to minus 2, if my value of n is minus 2, the value of n is minus 2, then this signal, the first sample of h of n minus k would be at minus 2, would be at minus 2. Then the same thing will be continued up till infinity, minus infinity. The same signal would be continued. If n is less than 0, then we'll have a situation in this way. It is our x of k and h of n minus k would be in this way. So it is line from minus 2, minus 3, minus 4 and so on till minus infinity. Now, if we go for multiplying these two signals, then they are not at all sharing the same. The multiplication of these two, to do the multiplication, the signals have to be present at the same time instances. But here, the one signal is on this side, and the other one is on the right side. So right now, multiplication of these two would give 0. So, if our n is equal to minus 1 also, then we could have a sample in this way. So that signal would be there from minus 1 to minus infinity. But even though there is a sample at minus 1, it will make our multiplication non-zero. So the multiplication is going to be 0. Hence, for any value of n that is less than 0, for any value of n that is less than 0, I have to result of convolution will be always 0. Now let's try with n greater than or equal to 0. When n is equal to 0, when n is equal to 0, then at h of n minus k, the signal is having its first sample at 0 and x of k is also having its sample at 0. So they both get multiplied and result is non-zero for k is equal to 0. Hence for n is equal to 0, for value of n as 0 in h of n minus k, the result will be non-zero. And if the value of n is anything that is positive, then our h of n minus k is going to come by that unit onto the right side, and some of the samples are going to be overlapped on x of k and h of n minus k. Both of them overlap and will give the non-zero result. Let's learn it with n is equal to 2. When n is equal to 2 in h of n minus k signal, then h of n minus k's, the very first sample will come at 2. So from 2 to minus infinity, that h of n minus k signal would be running. Then when we superimpose this one on x of k, so let's draw x of k and superimpose on it. So we can clearly see that the samples at 0, 1 and 2 get overlapped with each other and will have the multiplication, the convolution begins from 0, ends up at 2 because we don't have h of k on the left side, and similarly h of n minus k is not there on the right of 2. So from 0 to 2 will be our convolution limit. If we take n is equal to 4, if n is 4 and it's been superimposed on x of k, then the samples 0, 1, 2, 3 and even 4 get overlapped and will have the result of convolution as non-zero, and the starting limit is a 0 and ending limit would be 4. So in this way, whatever the value of n we can choose. If n is 10, then certainly the summation would start at 0 and end up at 10. So from 0 to 10, the samples would be overlapping. Similarly, we can choose generally any value for n. So our solution should be not specific, it should be generalized and acceptable one. So let's consider n as, let's consider the limit as yes. So our summation would become k is equal to 0 to n. So from k is equal to 0 is existing to from 0. Before 0, x of k is not s of n results have to be calculated. We can't have the multiplication happening before 0. So we can write s of n, s of n as is equal to is equal to is equal to summation. The starting limit of the summation is from k is equal to 0 because convolution begins from 0 and it ends at 2 here. It ends at 2 here. But generally, there is no restriction that we should take the value of k as 2. We can take any value. If k is 10, if k is if n is equal to 4, then at that time the first sample of the signal would come at 4 in this way. The situation would be, and it runs from 4 to minus infinity. Means n can be anything because our solution has to be generalized one. So k is equal to 0 to n. Whatever you take for n. If n is 1, then from 0 to 1. If n is 2, then 0 to 2. If n is 100, then from 0 to 100. Thus, x of k, h of n minus k. So x of k, h of n minus k, they are u of k and u of n minus k. U of k and u of n minus k are being substituted and given. So u of k is having its sample with unit value. Even u of n minus k is having its sample with unit value. When we go for solving, we can solve it in this way by splitting this power. And to get the answer of this summation, we use the mathematical formula this way. Alpha raised to k. Alpha summation k is equal to 0 to n. Alpha raised to k is nothing but 1 minus alpha raised to n plus 1 divided by 1 minus alpha. By using this, we write the solution as this way. So the entire solution becomes that half raised to n, and this value after simplification it gives 2 minus 1 by 2 raised to n. It is our resulting simplified convolution answer. Then this has to be represented in this way. So the result, let's draw in this way. It is S of n is S of n, and we can write this answer in this way. S of n, S of n, S of n is equal to it's 0. Our S of n is 0. Result is 0 if n is less than 0. And it is 2 minus 1 divided by 2. 2 divided by 2 minus 1 by 2 raised to n for n greater than or equal to 0. Means on this side we have our result as 0. It starts existing from here only. When n is 0 in this equation, it is 2 minus 1 by 2 raised to 0 is 1. So our value would be 0. So 2 minus 1 it would be. So its value would be 1. Then if n is equal to 1, for n is equal to 1, its value would be 2 minus 1 by 2 because half raised to 1 is half. So which will be 1.5. Then if 2, it is 1 by 4, 2 minus 1 by 4. So which is but greater than this 1 by 2. And when n is equal to infinity, it is 1 by 2 raised to infinity. Almost it is assumed to be 0. So in that case, it goes to 2. So this will be our problem. I hope you are understanding this one and try to solve some more problems of this type. And practice, let me know if any problem